Hello, everyone, and welcome to the University of Pennsylvania's Neuroscience Public Lecture Series. My name is Amanda Schott, and I'm a first-year graduate student in the Neuroscience Graduate Group here at Penn. Today's talks will be focusing on addiction, which is a complex and increasingly important area of research. Addiction is a broad diagnosis, and symptoms can manifest in all kinds of forms. You may have heard of addictions to things like sex, gambling, food, and many others. In fact, the range of potentially addictive subjects is so wide and so bizarre that the concept became fuel for a documentary television series. My Strange Addiction airs on TLC and has somehow found enough material for 6 seasons worth of episodes. Here we have examples of people addicted to things like eating drywall, smelling dead bodies, and snorting baby powder. These are some of the strangest cases of addictions that you'll ever see, but depressingly enough, addiction itself is very common. Today we'll talk about drugs of abuse because while probably no one here knows anyone who compulsively eats drywall, chances are someone that you know is addicted to tobacco, alcohol, or illicit drugs. In the US, approximately 23 million people struggle with a drug or alcohol addiction each year. That's nearly 1 in 10 people. Addictive substances cost the U.S. over $740 billion each year in healthcare, crime, and lost work productivity. Drug overdoses have doubled in the last 14 years and are now the #1 cause of accidental death in the country. This rise in overdoses is primarily driven by something that's often referred to as the opioid crisis. Opioids are drugs that bind to opioid receptors in the brain and body, taking away pain and giving the user an intense euphoric high. The epidemic started in the late 90s when pharmaceutical companies assured healthcare providers that there was no way that patients could get addicted to prescription opioid pain relievers. This led to a boom in prescriptions for drugs like Vicodin and OxyContin, many of which were abused before it became clear that the pharmaceutical companies were wrong. When the prescription runs out, addicted patients sometimes compensate by faking an injury to get another one, by stealing or illegally buying pain pills, or by turning to the cheaper street version, heroin. A 2014 study by the National Institute of Drug Abuse surveyed heroin addicts who started using drugs in the 2000s and found that 80% of them reported starting with easily accessible prescription pain pills. This is a dramatic change from the 1960s when the vast majority of opioid addicts started with heroin itself. Evidence of the opioid epidemic can be found all across the country, but it's hit Philadelphia particularly hard. These are pictures taken from Kensington neighborhood in Philadelphia, from a half-mile-long gorge that the DEA considers the largest heroin market on the East Coast. Addicts have been living, buying, and injecting drugs here for the last 30 years, surrounded by trash and contaminated needles. On the right is a shack that's known to residents as the hospital, where users can go and pay someone to shoot up heroin for them if they can't do it themselves. Kensington is the center of a heroin epidemic that has Philadelphia ranked 5th in the country for overdose deaths per 100,000 people, and the problem is getting worse. In 2016, 907 people in Philadelphia died of a drug overdose, a 30% increase from 2015. For reference, there were 277 homicides in the city last year. The overdose rate is more than triple that. As you can see from the map, many of these overdose deaths occur in Kensington, but many also happen all across the city. Opioids are responsible for a stunning 80% of drug fatalities across Philadelphia. In particular, the use of a drug called fentanyl, the red line on the graph, has been rising exponentially since 2013. Fentanyl is extremely strong, 50 to 100% more potent than heroin, and is occasionally prescribed by doctors for severe pain conditions. Fentanyl is also cheaper and easier to make than heroin, so illegal drug dealers occasionally mix it in with heroin or other pills in order to cut costs. This means that buyers could be consuming something that's many times stronger than what they expected, which has led to hundreds of accidental overdoses in Philadelphia alone. To understand how to combat this epidemic, we first need to understand the biological basis of addiction and how it is that drugs can have such a powerful hold on our brains. Addiction is a disease defined by habitual drug seeking and use in the face of negative consequences. These consequences can often be severe, including health concerns, financial problems, and social isolation. In the early 1900s, people struggling with addictions were considered morally flawed or lacking the willpower to kick the habit. Rehabilitation was not yet an option. Instead, the accepted treatment plan was to punish them by locking them up in drunk tanks or asylums. Today, the scientific consensus has changed, and addiction is widely recognized as a chronic disease that changes both the structure and the function of the brain. But how does it do that? So pleasure itself has a distinct signature in the brain. Any reward, like money, sex, a good meal, a positive social interaction, etc., results in the release of a neurotransmitter called dopamine. This dopamine release is located in a brain area called the nucleus accumbens, which is so consistently tied to pleasure that it's been nicknamed the pleasure center. Addictive drugs hijack this system by flooding the accumbens with 2 to 10 times more dopamine than natural rewards, resulting in intensely pleasurable experiences, or highs. Repeated exposures to these drugs can result in communication between the pleasure center and other brain areas that are involved in reward processing. One such brain area is called the prefrontal cortex, which allows you to plan and accomplish tasks. Communication between the accumbens and the prefrontal cortex gives drug users the motivation to go and get more drugs, continuing the cycle. Eventually, the constant influx of dopamine will overwhelm the brain, which responds by producing less dopamine and getting rid of dopamine receptors. This means that it will take more and more of the drug to feel the same high, an effect known as tolerance. At this point, drug seeking is no longer driven by pleasure, but by the memory of that first high and the desire to recreate it. The brain has become dependent on the drug, and any attempts to stop using it will result in symptoms of withdrawal, which are universally unpleasant and range from weakness and nausea to delirium, severe anxiety, seizures, and hypersensitivity to pain. These biological consequences make it extremely difficult to break the cycle of addiction. So, given the prevalence of addictive disease and the enormous physical, emotional, and monetary cost, it seems that research into this area is extremely important. Today, we'll hear from 3 faculty members at Penn who study different aspects of addiction, from molecular mechanisms all the way up to patient care. Here's our lineup for tonight. First, Dr. Mariella DiBiase will talk to us about her work in finding targets for drinking reduction therapies. Dr. Heath Schmidt will tell us about the possibility of using anti-diabetic drugs as treatment for cocaine addiction. And finally, Dr. Peggy Compton will speak about how opioid addictions can change a patient's ability to feel pain. We hope that by the end of the night, you'll walk away with a better appreciation of the neurobiological basis of addiction and how we here at Penn are trying to contribute to the global understanding and treatment of this devastating disease.